Hi, this is Mrs. Cribb, and this is the section that the honors have to cover that deals with limiting reactants and how to do calculations. And so pull up your notes. We are at section 911. We already talked about what a limiting reactant was. It was the thing that you get used up. And so how do we use that in chemistry? So this is an example problem. We have lithium hydroxide, and so lithium is Li and hydroxide is OH. And we have to figure out what the formula is. So hydroxide is a -1, and the lithium, what is a lithium? Well, you have to look at our oxidation chart for that. So hold on. Okay, I just pulled it up just to double check, and lithium is a +1 because lithium is in the first column, so it's an alkali. It's an earth metal. It's alkali metal. Not alkali earth metal. It's a metal. Anyway, column 1, 1 big electron, OH hydroxide ion. Swap and drop. So just the formula is LiOH. So we have lithium hydroxide, and so just LiOH. Canisters used on space shuttles capture exhaled carbon dioxide, so that's CO2 gas, and converts it to lithium carbonate. All right, so we got to figure out what lithium carbonate is. Well, lithium is the +1, and what is carbonate? Carbonate is CO3. And you can look at your polyatomic ion chart to double check that, okay? And what is the charge of CO3? Well, carbonate is a -2 charge. Carbonate is a -2 charge. So it's on the polyatomic ion chart. Now you swap and drop, so you end up with Li2CO3. So that's lithium carbonate, okay? And so it converts it to lithium carbonate and water, H2O. Okay, so we have this reaction that's going to happen. So the first thing we're going to have to do is we're going to have to write out the balanced equation. And we're going to have to write out the reaction to make sure it's balanced. So it just told us that we have lithium hydroxide canisters used on space shuttle to capture CO2 and convert it, produce lithium carbonate, Li2CO3, and water. All right, in order to do any kind of stoichiometry, we have to balance the equation first. So that's going to be our first job. Is this equation balanced? So I'm going to list the elements. We have lithium, we have hydroxide ions. I'm going to go ahead and circle it, and I'm going to change the water to H and OH so I can count the hydroxide ions. Well, is that going to help me in this case? Doesn't look like it because I don't have any hydrogens on this side that are separated. So we might as well just leave this as H2O. And I'm going to have to count the OHs, the hydrogens and the oxygens separately. So it doesn't always work out for you to do that. So we're just going to write OH. And I'm going to go ahead and count lithium, oxygen, hydrogen, and carbons. That's the kind of elements I have on both sides. So let's count. 1 lithium atom on this side. We have 2 because of the subscript. 1 oxygen here and 2 oxygens there. I like to connect them. 1 plus 2 is 3 oxygens on this side. Over here I have 3 oxygens and 1, so 3 plus 1, I have 4 oxygens on the other side. 1 hydrogen, and then on the other side I have 2 hydrogens. 1 carbon, and on the product side I have 1 carbon. All right, it's obviously not balanced. I need 2 lithiums, so I'm going to put a 2 in front, a coefficient of a 2, and recount everything. Now I have 2 lithiums, 2 oxygens, so that becomes 2 oxygens plus 2 oxygens is now 4 oxygens, and 2 hydrogens, and 2 lithiums. And look at that. The whole thing is balanced by just putting that 1, 2 in the front. So that's nice. Now I have the balanced equation. So I'm going to rewrite the balanced equation. So balancing the equation had to happen first. So first we turn the words into formulas. We wrote out the equation. We had lithium and CO2 producing lithium carbonate and water. We balanced the equation. Now we're going to, I'm going to write out the balanced equation so I can do some more math. And you need to write small for this one, let me tell you, because there's a lot to put in whenever you have a limiting reactant question. And this is really important for especially honor students to get all of this. All right, now let's read the rest of the question. If a set of canisters contains 5,750 grams of lithium hydroxide, so 5,750, notice there's a dot, grams of lithium hydroxide, and each of 6 crew members exhales 21 moles of carbon dioxide daily. All right, so let's think about that. We have 6 crew members, and they exhale 21 moles of CO2 every day. How many moles of CO2 is that? It was just 6 times 21. Because I stink at mental math on the fly, I'm going to multiply it out. 6 times 21, I got 126 moles. 126 moles of carbon dioxide. Okay, so we have 126 moles of carbon dioxide. Will the lithium hydroxide canisters be a limiting reactant for that day? All right, so here's where it's going to be weird. We don't have a question like one with a question mark. What we have are 2 reactants, and I need to figure out if the reactants get used up, which one gets used up, and if it does, is it the lithium hydroxide? I need to figure out which one of these reactants limits the amount of products I can make. So I'm going to write out the pathway. We have the mass of A goes to the moles of A, to the moles of B, to the mass of B. We turn the mass of A to moles of A using the molar mass of A. This is the ratio B over A, and the moles of B to the mass of B using the molar mass of B. Okay? Now, before we've had an A, which was our known, and B was our unknown. Right now we basically have 2 A's. So this is what we do. We choose one of these 2 guys to be our B, and it doesn't matter which one. I'm going to choose water. Why am I choosing water? Just because it's a smaller molecule than lithium carbonate. So I'm going to choose water, and I'm going to see how many moles of water I'm going to be able to make. So this is going to be my B. This is going to be my A1, and this is going to be A2. I have to do 2 sets of calculations. I'm going to start out with the A1 and see how many moles of water this amount of lithium hydroxide will make. Okay, so let's do that first. All right, we start with what we know. And like I said, you have to write small. So 5,750 grams of lithium hydroxide. And so I'm starting with mass of A. To go to the moles of A, I need the molar mass. So I need the molar mass of lithium hydroxide. I'm going to calculate that right here. Lithium, oxygen, hydrogen. I'm looking on my periodic table. Lithium is 6.94, and there's one of them, 1 oxygen, 1 hydrogen. So 6.94, oxygen 16, hydrogen 1.01. Okay, so let's add those all together. 6.94 plus 16 plus 1.01, 23.95. That's how many grams per mole. This is the molar mass of A1. Okay, so I'm going to turn mass to moles using the molar mass. So I put 1 mole on top and 23.95 grams on bottom. This is the molar mass of A1. Okay, that gets me to here. I want to go to moles of B, which is my water. I want to go to there, so I just need to use the ratio of B over A next. So if I look at my balanced equation, you notice there's 1 mole of water, B, 1 mole of the B molecule over 2 moles of the A molecule. And I'll be able to tell you how many moles of water are created if I start with this amount of lithium hydroxide. All right, let's do the math again. 5750, oops, that's not 5750, 5750 divided by 23.95. Okay, divided by 2 because the 2 is on the bottom. So I got 120.04. And then I look for sig figs, and this has 4 significant figures. So I need 1, 2, 3, 4. So that's 120.0 moles of water. That's my first answer. So you're going to end up with 2 answers here. You're going to end up with an A1 answer and an A2 answer. So my A1 answer is 120.0 moles. All right, I got to figure out an A2 answer now. So now I'm going to start with A2, this one here. So I start with, this time I have moles. So 126 moles of carbon dioxide. Well, where in my pathway am I starting now? I'm already here at moles. So I just got to go from moles to moles using B over A. So this one's an easy calculation. So B is still 1 mole of water, and A is 1 mole of carbon dioxide, and it's a 1-to-1 ratio, so moles cancel. Up here we cancel 2 moles, lithium hydroxide. And so now it's just 126 moles of water for the second question. And it's only 3 sig figs. All right, so I started, what I did with the first one is I assumed that if I used all of this up, so this is using it all up, this is using all 5,750 grams up, I could create 120 moles of water. Now that would mean I have more carbon dioxide than I need. I'm just basing it on if I use all of this up and I have more than the other stuff than I need, how much water would I create? 120 moles. This one is saying if I have 126 moles of carbon dioxide and I use it all up, so use all CO2 up, and I have more lithium hydroxide than I need, I would create 126 moles. Only one of these answers is correct. The answer that is correct is the smaller value. This one. That's the most amount of water I can make. So this one is the smaller amount. The smaller amount is the most you can make. Why? Because when I make 120 moles of water, I have used all of the lithium hydroxide up, and now there's no more left. So I can't keep going. I ran out of lithium hydroxide. Okay? So lithium hydroxide then is the limiting reactant. So the one, whatever this is a smaller, the thing that it starts with is the limiting reactant. This 120 is a smaller number, so that is the limiting reactant that stops the equation from going forward. What does that also mean? That means that carbon dioxide is, I have that in excess, the excess reactant. In other words, I have more carbon dioxide to react than I use up. I have some left over. It's like the hot dog image in the previous video where I had, 1, 2, 3, 4 hot dogs, and maybe I had 5 buns. Okay, I put these together, I have a bun left over. That's the excess reactant. This one, since it all gets used, that's the limiting reactant. So the lithium hydroxide got all used. It's the limiting reactant. The one that gives you the bigger number is the excess reactant. So if a set of canisters contains this amount and 6 crew members exhale 21 moles, will the lithium hydroxide canisters limit the reactant for the day? Yes. Yes, it will. Because it's the limiting reactant. Write and balance the equation first. Okay, now that's the first one, so make sure you get all that in there, because we have to use this data in the second question. So you notice we had 2 stoichiometry calculation sets in this one. This was the first one and the second one. And we started and ended in a slightly different place. Okay, now, how many grams of excess reactant are there? Okay, what is the excess reactant? CO2 is the excess reactant. We have too much of it. right? We started with 126 moles. That's too much. So I need to know how much do I actually use up, okay? So in my little example here with hot dogs and buns, there would be one bun left over. That's what I'm asking. How much of the CO2 is left over? Okay, that means if I know, I want to figure out how many buns are left over, what do I have to first know? How many did I use? Okay, so I have to do the same thing here. CO2 is excess. This is too much. So how much did I use? To figure that out, you start with the excess reactant, 126 moles of CO2. And I needed, the first question is, how much do I use? That's what I'm trying to figure out. So I go back to the balanced equation. I'm going to write the balanced equation back down. Let's see here so we can work with it. 2 lithium hydroxide moles plus a CO2 mole gives you lithium carbonate and water. Okay? All right, now I know that when I use the 5,750 grams of lithium hydroxide, I only create 120.0 moles of water. So I want to know how many moles do I need? How many carbon dioxide moles do I need? So that makes this thing the A and this thing the new B. So what does that mean about this? This means I set this up wrong. I'm not starting with the 126. I'm starting with the amount that I know gets used. All of this is used. I mean, all of this is created. Okay? So how much is used over here? So let's erase this. And let's set it up. All right, so I start now with the amount that I know for sure I create. 120 moles of water. And I'm trying to figure out how much CO2 do I use or do I need. Okay? So I have A, and it's in moles, and I need B. And since CO2 is in moles, I need B in moles. So I got the moles of A ratio to the moles of B using the molar ratio. So it's an easy conversion, okay? The moles of A is, I know that the only amount of water I create is 120 moles. Why do I know that? Because I use all 5,750 grams of lithium hydroxide, and I could only make 120 moles of water. So I take 120 moles of water, and I use the ratio B over A. So there's 1 mole of CO2 right there for every 1 mole of water. Well, it's a 1-to-1 ratio. That makes it an easy calculation. So 120.0 moles of CO2 are used or needed. Okay? That's not the question though. How many grams of excess reactant are there? Well, right now I tell you how many grams are needed. So once I know that, I take the amount that I have minus the amount that you need, and that's going to give you your excess amount, okay? So what do I have for CO2? I have 126 moles. I subtract out the 120.0 that I need, and I end up with 6 moles excess of CO2. Do you see this equation? The amount that you have minus the amount that you need or the amount that you use gives you your excess amount. So my excess amount is 6 moles. I have 6 moles too much. Well, that's fine, but the question is grams, so I got to turn that to grams. So 6 moles of CO2, and I have to know the molar mass. 1 mole is what, because I'm turning moles to mass now. So I need the molar mass of carbon dioxide. Okay? So C1, oxygen 2, carbon is 12.01. This is 32.00 plus 12.01. This is 44.01 grams per mole. That is the molar mass of CO2. So 44.01 grams. Moles cancel out, and I end up with grams. So 6 times 44.01. 6 times 44.01. 264.06. So it's 264.06. There's only one sig fig in this thing. Let's see. No, actually we should have had 3 sig figs. So, well, no, just go to the ones place, because when you're subtracting, you only go to one place. So this would round to about 300 grams of CO2, because 1 sig fig. Now that's an involved question, isn't it, guys? But this is okay. This is something that you can do if you're very careful. It's the same process all the time. Now notice there's an extra credit opportunity here. But the process for limiting reactants are, you're going to start with, you're going to have an A1 and an A2, and you're going to have a B. And you're going to end up with 2 answers, an A1 answer and an A2 answer for the B, because the B is going to have 2 answers. Okay? The smaller one is the one that happens. And the bigger one is where you get your excess reactant from. The smaller one is where you get your limiting reactant from. Okay, when you want to figure out how much is left over, how much is left, or what is the excess, or how much too much, it's always what you have minus what you need, or whatever gets used, either way, to give you your extra or your excess. And that unit can be grams or moles depending on the question. Okay, we're going to have plenty of practice with these, so I hope this helps, and I'll see you soon.